Hey guys, welcome back to Math Hacks. Today you get to learn how to solve a system of 3 equations using matrices. In the last episode of Math Hacks, you learned how to solve a system of 3 equations using the back-solving method, which was an awesome algebraic approach. Today, we get to move into the more commonplace method for solving systems of 3 equations, and that's by using matrices. Now, don't worry if this is the first time you've ever used matrices or maybe even heard of matrices. Today's tutorial is going to be beginner-friendly and will serve as a wonderful introduction to matrices. Let's get started. So today we are learning how to solve a system of 3 equations using the Gaussian elimination or row reduction technique. If you are in linear algebra, then you're in the right place. This is the technique that you would need to know to solve a system of equations in that course. If you are in pre-calculus, you may also be learning this. And if so, this is probably your first introduction to matrices, so how exciting. Matrices are just a cool little notation that we can use to do a lot of complex math really simply. And the nice thing about matrices is they allow us to let go of all those variables temporarily and just work with the numbers. So although you may feel intimidated by the notation at first, it's actually a really handy tool that you'll probably end up liking. So there's a lot of new terminology today. The first term that you probably have noticed already is the process that we are learning called Gaussian elimination. This is also sometimes called row reduction because we are going to be reducing the rows in our matrix into a nice form called triangular form or reduced row echelon form. So our goal today is to solve this system of equations. So by solving it, what I mean is I want to find the value for x, y, and z that when I plug it into this system, all 3 of these equations come out to the numbers that they say they should. If you want to think about this in a more geometric way, these 3 equations represent planes, and we are finding the place where all 3 of these planes intersect, if there is one. The first thing we need to do is rewrite our system as an augmented matrix. And I know that sounds scary, but all it is a matrix, which is a big bracket with the numbers that are the coefficients on each of these values and the numbers that they're equal to. And I'm going to copy them down just exactly in the order that they show up here. So in this first one, I can go ahead and write in a 0x to remind me that I have 0 x's. And here I have 1x already written down for you. And on the z, we can remember that this is the same as 1z. So basically, I'm going to make a matrix where I have 0, 2, -8, and 8 in the first row, 1, -2, 1, and 0 in the second row, and -4, 5, 9, and -9 in the third row. So if you're brand new to matrices, this is what a matrix looks like. It's just a couple big brackets with numbers organized in rows and columns. The augmented matrix just means that I took the coefficients from my system of equations along with what they're equal to and transcribed them into my matrix form. So that is the first step. Now, before I jump into the second step, I need to do a little bit more explanation about where we're going and what we want to do. So our first goal with this matrix is to manipulate it so that we have it in what we're going to call row echelon form, which is also known as triangular form. Let me show you what that is. So this is row echelon or triangular form. And what's special about it is that what we've gone and done is we have made a triangle of zeros in the bottom left-hand corner surrounded by a line of ones. And then the rest of the values in the matrix can just be whatever numbers arise as we manipulate this matrix into this form. And what's really nice about this form is that each of these columns represents the coefficient on one of our variables. So you'll notice that if we look back at how we set up our matrix, everything in this first column is the coefficients on the x variable. So to remind us of that over here, I'm just going to write an x above this column. Everything in the second column is attached to the y variable. Everything in the third column is the z variable. And then everything in the last column are just the values that they're equal to. So I'm just going to write a number sign above it. So getting this into row echelon form will help us because just by looking at it, we'll know what the z solution is. Because in this third row here, I'll have 0 x's, 0 y's, 1 z equal to a number. So that basically tells me that z is equal to this number. I could then use back solving to plug it into this equation to figure out what the y variable is, and then plug both of those back into the first equation to figure out what the x variable is. At the end of today's lesson, I'll show you how we can manipulate this matrix even further to get it into what we'll call reduced row echelon, where you won't have to do any of that back solving. You'll be able to just look at the matrix and read off the solutions, which is really nice. So how do we get our augmented matrix into this form with the zeros and ones where we want them to be? To do that, we have a set of rules that I've outlined up here. So these are the legal moves that you can use to manipulate your augmented matrix so that it's in this form at the end. The things you're allowed to do are swap rows. That means that I could switch rows 1 and row 2 or row 1 and row 3. Secondly, I can multiply any row by a constant. That includes multiplying by a fraction, which will basically be the same as dividing. And I'll show you how that's handy as we work through this problem. And thirdly, I can add rows together. Of course, if I've multiplied by a negative number here, that's the same as subtracting. So you can think of this as adding or subtracting rows together. Although this may sound a little bit complex right now, as you work through these problems, you'll see that the process is pretty straightforward, and once you do a few problems, you'll have the hang of it. So we want to, in step 2, work strategically through this matrix to get it into row echelon form. And you always want to work through it in the same order because it's the order that works. So the first part that you want to work on is getting a 1 in this first row, first position. And as we move through our matrices, I am going to be referring to the rows a lot. So let's write down a little notation for them. Row 1, I'm going to write as r with a subscript of 1. To refer to row 2, I'll have r with a subscript of 2. And to refer to row 3, I'll have r with a subscript of 3. We're going to have a tiny bit of notation that will help guide us through these problems in each step. So you'll see these popping up a lot. All right, so our first task is to get a 1 in row 1 x position. So that is right here. And I can do that by using any of the rules that I've outlined over here. Now, just on first glance here, I see that the values I have in row 2 already have a 1 in the x position. So the easiest way to get a 1 here is simply swapping rows 1 and rows 2. The notation I'm going to use for that is going to look like this. So I'm just going to write down that I'm going to swap row 2 with row 1 with a little double-ended arrow here. And this is not necessary, but in most textbooks and professors will use some variation of this kind of notation to help guide them through the problem, because as you work through it, it's easy to get yourself confused, and it's really nice to just write down what you're doing before you start manipulating these rows. So in this second step, I am going to just swap row 1 and row 2. So the way I always start these problems is if there is a row that I'm not doing anything with, I just go ahead and copy it down first because that row is just going to stay the same. So the first thing I'm going to do in this step is I'm just going to rewrite row 3 on the third row because I'm not going to do anything to that row in this step. Next, I'm just going to use a different color to help you see that I am swapping rows 1 and rows 2. So row 1 will go into the second position this time. So I'll put 0, 2, -8, and 8 here. And then row 2 is going to go into the first row. So I'm going to write 1, -2, 1, and 0 here. So that gets a 1 in the first position. So that's all we need to do right now to change out the first row. Now let's go to the second row. And I always want to start with the x position first. So I want to get a 0 in the x position of row 2. So that is this value right here. And I'm lucky in this problem because it already is 0. So step 2 is completed for us. That means that we can go ahead and move on to step 3, which is to get a 1 in the second row, second position. So now we're moving on to this spot. So I just noticed that I wrote down the second step wrong. You want to get a 0 in the second row, x position, not y position, first. And then you want to get a 1 in the second row, y position. So just make sure you have that straight. So how are we going to get a 1 in this position of my matrix? Remember that one of the things I can do is multiply by a constant, including fractions. So if I want to make 2 into a 1, I have to divide the entire second row by 2. Now that's the same as multiplying by 1/2. So what I'm going to do next is I am going to take row 2 and multiply it by 1/2. So in my little notation to guide me, I'm going to write 1/2 times row 2. And then I'm going to put an arrow. So that's just going to tell me where this row is going. So I'm just replacing the same row. So that's just going to be the new row 2. So 1/2 of row 2 becomes row 2. Again, I'm going to start by copying down any rows from the last matrix that I'm not going to change in this step. So that means that the first and the third row can just be copied down since they're not changing. Now I am going to take half of row 2 to replace row 2. So half of 0 is still 0. Half of 2 is 1. Half of -8 is -4. And half of 8 is 4. All right, so that gets a 1 in the second row, second position. Now we can move on to the third row. And in the third row, we want to start by getting a 0 in the x position. So that is our next goal. So how am I going to get a 0 in this first position of the third row? Remember, some of the things that we are allowed to do are swap rows, multiply by constants, and add rows together. For step 4, we have to do a combination of a couple of these. So it's a slightly more involved step than we've had so far. What I'm going to do is I'm going to take a multiple of the first row and add it with the third row so that I get a 0 in this first position. Since I have a 1 in the x position of the first row, I can multiply it by 4 and then add it to -4 to get 0. Of course, I have to do it to the entire row and add the entire row to the last row. So that's what I'm going to do on this next step. To guide me, I am going to write down the directions that I'm going to do. So I am going to take 4 times row 1, so 4 row 1, and I'm going to add it to row 3, so plus row 3. And then I'm going to put an arrow and tell myself which row I'm going to write that in. And I am going to write that into row 3. Let's start by copying down the rows that aren't going to change at all in this problem. So since I'm only changing out row 3, row 1 and row 2 are going to remain the same. So my first step is to write down the values in those 2 rows. Now we are going to multiply row 1 by 4 and add it to row 3 to get the new row 3. So 4 times 1 is 4, plus negative 4 is 0. 4 times negative 2 is negative 8, plus 5 is negative 3. 4 times 1 is 4, plus 9 is 13. And 4 times 0 is 0, plus negative 9 is still negative 9. All right, so we have succeeded at getting a 0 in row 3 x position. Looking back at where we're going, we want to also get a 0 in the y position of row 3. So that is where this negative 3 is right now. Now, as you can tell, we're working very strategically through this matrix, so it won't be too hard to get a 0 here. All I have to do is take 3 of row 2 and add it to row 3 because I have a 1 right here. So 1 times 3 is 3, plus negative 3 is 0. So that's how I know I want to take 3 of the second row and add it to the third row. So I'm going to write down my directions first to keep me organized. I'm going to take, I said 3 of row 2, so 3 times row 2, and I'm going to add it with row 3, and that is going to make my new row 3. So that's where I'm going to place it. Next, I will go ahead and copy down rows 1 and 2 since they are unchanging in this step. Next, I'm going to go ahead and make my new row 3. So I'm taking 3 of row 2 and adding it to row 3. So 3 times 0 plus 0 is still 0. 3 times 1 plus negative 3 is 0. 3 times negative 4 is negative 12, plus 13 is 1. And 3 times 4 is 12, minus 9 is 3. All right, so I've succeeded now in getting the zeros here and here. And fortunately for me, we also happen to get a 1 here. So the next step is already finished for us, which is to get a 1 in the third position of the third row. So I'm just going to write that down just to have good notes over it, even though we've already accomplished our step 6. So we have accomplished getting our augmented matrix that we started with into row echelon form or triangular form, where I have these 3 zeros in the bottom left corner followed by a row of 1s. So here we have a couple of options. If we want to quit working with matrices, we can translate our matrix in triangular form back into a system of equations like up here. And once I do that, I would see that z is equal to 3, and then I could plug that z value back into the second equation to get the y value, and then plug both of those values back into the first equation to get the x value, and then I would have solved my system of equations. So if I quit at row echelon form, I have to do a little bit of back solving, but it's pretty easy back solving. Now, especially if you're in linear algebra, they're probably going to ask you to keep reducing this matrix. So now we are going to go from row echelon form into reduced row echelon form. And the wonderful thing about reduced row echelon form is we will be able to directly read off the solutions for x, y, and z from the matrix. So let me go ahead and show you how that's going to work out. So for our final series of steps today, we are going to take the matrix that we left off on the last page and we are going to manipulate it into reduced row echelon form. So the difference between row echelon form, which we're in already, and reduced row echelon form is now we are trying to get zeros in these positions right here. So that means in the first row I have just 1, 0, 0, and then some number. In the second row I'll have 0, 1, 0, some number. And then in the third row I'll have the 0, 0, 1 number, just as I left off in row echelon form. This is really handy because if you recall, the numbers in column 1 represent the x values. Numbers in columns 2 represent the y values. In column 3 represents the z values. And then the numbers in column 4 are simply the numbers, which will act as our solutions. This tells me that 0x plus 0y plus 1z equals a number. Okay, so that's the solution for z, since z equals a number. In row 2, I'll have 0x's, 1y, 0z's equal to a number. So that'll tell me that y equals this number. And in the first row, I'll have 1x plus 0y plus 0z equal to a number. So that tells me that x equals this number. So basically what I can do when I get it into reduced row echelon form is I can directly read off the solution to our system of equations. So we're going to use the same rules that we've been using so far to manipulate our matrix. We can swap rows, we can multiply by a value, and we can add and subtract rows. So I want to continue working through this matrix strategically. And the order that we kind of attack each of these spots is really important because it makes life a lot easier if you do it in the order that I'm showing you. So just like we worked our way down, getting the zeros and ones in this direction, we are going to work our way up now. So that means that we want to get a 0 in the second row, third position, next. To do that, you are always going to use a multiple of row 3 to manipulate row 2. And that's because I already have zeros here and here, so using a multiple of this row will ensure that I don't mess up the values in these two positions. All right, so the next step is to get a 0 in row 2 z position. Once again, I am going to write out the steps that I'm going to do to get a 0 in this position. So since I have a -4 here, I can take 4 times 1 and add it to it to get 0. So that is going to look like 4 times row 3 plus row 2. And I'm going to insert that into row 2. Just like before, I will copy down the rows that I'm not going to change. So since row 2 is the only one changing, I am just going to copy down rows 1 and rows 3 first. Now I am going to take 4 times row 3 and add it to row 2. So 4 times 0 plus 0 is 0. 4 times 0 plus 1 is 1. 4 times 1 is 4, plus -4 is 0. 4 times 3 is 12, plus 4 is 16. All right, so now that I have the pattern 0, 1, 0, then a number, I have completed row 2 in my reduced row echelon form. Now I'm going to work on row 1. Just like we've been doing, I am going to strategically work my way up by focusing next on the z in the first row. So I want that to be a 0. Now you'll notice that in order to get a 0 in the z position of row 1, I need to take -1 of row 3 and add it to it. That -1 plus 1 will give me 0 here. So -1 times 0 plus 1 is 1. -1 times 0 minus 2 stays minus 2. Negative 1 times 1 is negative 1, plus 1 is 0. And negative 1 times 3 is negative 3, plus 0 is negative 3. All right, so now I have the 0 in this position, and the last place for me to get a 0 is going to be in row 1, y position. So to do that, I'm going to use a multiple of row 2, since row 2 has a 1 right here, to get this to be 0. To do this, I am going to take 2 of row 2 and add it to row 1. So 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus negative 2 is 0. 2 times 0 plus 0 is 0. And 2 times 16 is 32, minus 3 is 29. All right, so we have accomplished getting our matrix into reduced row echelon form. And this will make it really easy to read off the answer. Our last step is to read off the solution. So looking at this matrix, what it tells us is that, remember, this row represents x's, y's, and z's. So we know that x is equal to 29, y equals 16, and z equals 3. So that's the solution set. If you learned something new today, if you liked this tutorial, or if you just want to see more math hacks in your feed, there are 2 super easy things you can do to make that happen. 1, give this video a big thumbs up to let me know you learned something new. 2, don't forget to click that subscribe button and join the Math Hacks community. Till next time, I'm Brett, and thank you so much for watching.